In the last video, we explored arrays, and specifically we were looking at single-dimensional arrays, and this was material out of Chapter 7. And when we did that, if I take you to the Liang samples, we looked at this analyze numbers example, which, if you'll recall, we were calculating the average, and then we had to find out how many numbers were above the average, and hence we needed an array to keep track of those. And then another example that I gave you was from my own example called parallel arrays, this notion that we might have multiple arrays where the same element in each array kind of refers to the same thing. So here we have accounting department, how many students are in accounting, finance, how many students are in finance, CIS, how many students are in CIS, etc. And we're going to come back to some Chapter 7 material because there's going to be methods involved, and we're going to come back and explore this combination of using arrays with methods. For this lecture, I'm going to want to focus on Chapter 8 material, which is multidimensional arrays. And once again, that's this right here. And really, you can think of a multi-dimensional array, let's say a two-dimensional array. A two-dimensional array as being an array of arrays. And if it was a three-dimensional array, you can think of it as being an array of arrays of arrays. It's only when you get down to that last dimension that you actually have the kinds of objects or data. So if this was an integer, a two-dimensional integer array, it would be an array of integer arrays. The indexing into multidimensional arrays, you can see this in the case of a two-dimensional array, there's going to be two indices. In the case of a three-dimensional array, there would be three indices. And with a two-dimensional array, you can kind of imagine it as being one dimension is rows and the other dimension is columns, kind of as if this was a table or a grid in a two-dimensional array. And we'll look at some of that stuff as we progress further. So declaring much the same as with one-dimensional arrays, except that you have an extra set of braces here. So this right here is indicating that we have a two-dimensional integer array called mylist, which, as I said, is an array of integer arrays. And you can do the brackets after the name instead of after the data type if you like. I prefer the syntax above. And instantiating, same thing. The new keyword, remember, you had to do that. But now when you're instantiating a two-dimensional array, for example, you're specifying, the first dimension size, and you're also specifying the second dimension size. So this right here is showing that we have an array of double arrays. So we actually have 10 of these double arrays, and each one of the double arrays will have 4 doubles in it. So there's a total of 40 doubles total in this. But keep in mind, this is an array of arrays. And again, this use of the new keyword, the heap, all that kind of stuff we were talking about before. And you can do the declaration and creation in one step, just like you could do with a single-dimensional array as well, or for that matter, with other kinds of variables. When you declared your scanner object, you declared and you instantiated it all in the same fell swoop. And here shows you a couple of ways that you can initialize arrays. One way is through the use of a nested loop. So remember when we were working with single-dimensional arrays, we used a loop. When we're working with two-dimensional arrays, we'll often use nesting too deep of our loop if we want to get through each and every one of them. And if we were using three-dimensional arrays, we'd be nesting 3 deep if we wanted to get through all of them. As a matter of fact, we're going to see examples of this. So if we wanted to just set initial values, we can do it in a loop like this. Or alternatively, this right here is showing a way of doing this statically. And we can see that what we have here, my list, is an array, and each element of that array is itself an array. So again, as I said before, if you have a two-dimensional array, it's an array of arrays. And then finally, each of the individual elements are going to be whatever the data type is. And in this case, it was double. So those are two alternative ways of initializing values. And I'll show you a couple of examples to illustrate this. The first example is something that I just put together myself, so it's available in that arrays package that, if you recall from the last lecture, I had downloaded that. You have access to it from Canvas. And this is called Multidimensional Array. And I'm just going to run it so you can see what it's doing. So here's what the output looks like when I ran it. It was a two-dimensional array, and I'm keeping track of the row number and the column number, what I'm calling row or column in this two-dimensional array. And let's see what I've done here. I have, first of all, notice I'm using constants here. So here was a useful use of constants. So I'm specifying I want to have 5 rows and 4 columns. And you'll notice that I'm using rows in a certain place and columns in another place. And one of the reasons for using these things is to specify what the size is. And the other is to specify the ending condition for each of the loops. And you'll notice that I have one loop here that's basically assigning values into the elements of the array. And so this is similar to what I had shown you in the PowerPoint slide a moment ago. And then I have another loop that's actually printing out values. And in both cases, I'm using rows and columns to specify. And so if I said, no, I don't want to have 5 rows and 4 columns, I want to have, say, 7 rows, but only 3 columns. And I only have to change it in one place. And now if I run it, there I have it. So one of the advantages of using constants, and especially if it's going to be pertaining to a value that you're going to be using multiple times in your code, you would otherwise have some literal value or something that you would be using multiple times, and then have to change it multiple times if you wanted to make it flexible enough like that. And otherwise, you can just do it by having a constant and just changing that constant when you want it to have different values. So as I said, this first loop right here, this nested loop, I is going to be basically going row by row, if you will, and J is going to be going column by column within a row. And if I wanted to set a breakpoint, I think I will, and we'll see how it behaves. Maybe I'll put a breakpoint before the for loop, and I'll put a breakpoint here right before when I'm going to be doing the printing, and maybe I'll even put a breakpoint right here before I've instantiated this multiplication table thing that I called. I guess it's really not a multiplication table. I must have been using this code for something else. I shouldn't call it a multiplication table. But anyways, it is what it is. Let me debug it. And here we have this, if I look in the debugger and I want to see what's there. You'll notice I don't see my variables here. So let me go into Window. If I'm missing something that I want to see, in NetBeans, I can go to Window, and then I go to Debugging, and there's a variable. So I'm going to go ahead and put that in there, and there's the variables right there. So here's my output, and here's my variables. And I got rows and I got columns. They're really not variables. They're really constants, as you know. They're final. So that means they can't change. But I don't yet have multiplication table, as we shouldn't be surprised by, because we haven't declared it or instantiated it yet. But now I do. And let's take a look at what multiplication table has. First of all, the data type is string in this case. And so we can see that it is an array of string arrays. Here it's an array of what? Of string arrays. And if I expand on it, there's actually 5 elements in this array called multiplication table. And each of those elements are themselves an array of strings, as you can see here. Each element of multiplication table is an array of strings. And at this point, these are basically reference. Remember, strings are not primitive data types. So these are references, and so initially they're null. They don't have anything in them. And so the purpose of this loop will be to actually put something in them. And let's go ahead and do that then. So I'm going to go here. So here now, we're about to assign a value. And watch what happens. We assigned a value, and now we're going to assign a value to the next one, and now to the next one, and now to the next one. And at this point, I is about to become 1 here, because now we're at the, actually we had dropped into the outer loop the second time here. I is 1 now, j is 0 again, and we're, well, we've just dropped into this j loop from above. So this is, we're in the second time in our outer loop. And within that outer loop, once again, we're the first time within our inner loop, and we're going to see the same thing start to happen in this element here. And let's do it. And you can see things happening here. And so you have a little flavor for what's taking place. So initially, those string variables had no values in them, meaning they weren't pointing to anything, any object on the heap. But now they are pointing to actually string values that are in the heap. We'll talk more about strings in a future video. And now, once I get done with, and I'll just take the breakpoints off of these, once I get done with this loop, and I'm about to enter the second loop, and now here we are at the point where we're going to be able to actually use this data. So our zeros are all filled, our ones are all filled, our twos, all the way down to our fours are all filled, as you can see. And now we're going to be able to actually start putting stuff out there. And notice, by the way, at this point, once again, to point out to you, there's no I, there's no J, because the scope of these are within the loop. So as long as the loop was going on, there was an I. As long as this loop was going on, there was a J. And so at this point, we don't yet have an I. I'm going to break into, I'm going to just stop right here. At this point, we do have an I, but we don't yet have a J. At this point, we have an I, and we have a J. And if I was to look at what's in the multiplication table at that position, well, first of all, if I just look at what's in multiplication table I, we can see that it's an array of length 4. But if I wanted to look at multiplication table IJ, we can see that it has that particular value in it. Just to illustrate again, the J disappears. I'm going to put a breakpoint right here. So we'll go back up to the top of the loop, I think. Oops. I guess we don't. Actually, I'll put my breakpoint right here. I'll put my breakpoint right here where I'm about to print out a line. Remember, on each of these, I was just printing with tabs. All of this came on the same line. And now I'm about to print out a line. So let's get done with this particular one. So I still exists, but J doesn't anymore. But now, J is going to exist again. It's going to be incrementing. And then it doesn't exist anymore. And again, has to do with variable scope. And we'll be talking more about that, especially when we get to methods. And again, at the end, we have this kind of output. So that should give you a little taste for how we had initialized the values of the array elements in a loop. And that's similar to what we see here in the PowerPoint. Just to illustrate, you can use the length, although I used a constant for looping, we can use the length of the array. We saw that happening here. And keeping in mind that each element of that two-dimensional array is itself an array, And notice that here I'm using R as my outer loop counter and for row, I guess, and C as my inner loop counter for column. And notice I'm checking to see that C is less than not the overall array length, my list.length, but the length of the array at position R. And so that's how we're checking to see how much we want to loop in the inner loop. And we'll see some examples of that. So this one is listing 8.2 called GradeExam. It's an interesting little example. There is a two-dimensional array called answers, and then there's a one-dimensional array called keys, and both of them are the same type, char. And the answers are each element of that two-dimensional array is itself an array. And these are the answers that students gave. So student 1, student 2, student 3, student 4, student 5, etc. All of these students gave these answers to the test. And what's going to happen is that this is going to grade each of the tests. And we'll find out how many they get right for each of the tests here. And so that's what this is doing. And you'll notice the declaration of the two-dimensional array here. Again, it's declared as an array of arrays. Notice again, char data type, single quotes, right? This is not a string. And if it's not a string, that means it is a primitive data type. And we have the one-dimensional array. And here we have our nested loop as we saw before. So we're looping through each of these students, if you will, in the outer loop. And we're looping through each answer in the inner loop. So notice in the outer loop, we've got within the block of the outer loop, we have this variable called correct count. That means that's only going to exist as long as that block is in execution. It's not even going to exist as long as I exists. I exist throughout all of the iterations of the loop. But correct count only exists within the block. And then it disappears. And then another correct count comes in. And then it disappears. And then another correct count comes in. So for each student, we're making a brand new variable called correct count that's only going to last as long as the block is executing and can only be accessed from within the block. So the duration is only as long as the block is executing, and the scope is only accessible by other instructions within that block. Another example of variable scope. So answers, that had method scope. That's available for the whole method. Key is the same thing. I had loop scope. It's available throughout the whole loop. Correct count has block scope. It's only available within the block. So answers.length is the length of this array, which is 1, 2, 3, 4, 5, 6, 7, 8. For any given I, because all of these arrays are of the same length, they're all 10, answers at position I.length is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you really want to know how many total elements there are, you would be multiplying answers.length times answers I.length. And this is, again, of the assumption that they're all of these individual arrays are of the same length. They don't have to be. We'll get to that in a bit. As a matter of fact, I'll get to that real shortly, but let me just run this. So here's GradeExam. Let me go ahead and put a breakpoint right at the beginning of this loop. We can take a look and see what each of these variables look like. We'll debug it. So here we are, going into the variables. There's answers. And there you have it. And each one is a char, as you can see. And there's one array for each of the students, numbers 0 through 7. And then here's keys, as you can see. And let me also point out there's no I yet, and there's no correct count, of course. Let me do this. I'm going to put a breakpoint here. I'll put a breakpoint here. I'll put a breakpoint here. And let's see what happens here. I exists now. Correct count exists, and we're in the loop, so J exists. And we'll start to see correct count incrementing. As you can see, not always, because they're not all correct. And now we're done. J no longer exists. Correct count still does, though. I really don't know if this goes up to the top of the outer loop or not, will it? Yeah, unfortunately, well, I guess we do see this. Now we've dropped into the outer loop second time. I is 1, and correct count doesn't exist yet until it comes into being again. So you can see that illustration of this scope and duration thing going on. So that's one of the examples. Now, as I said, this was under the assumption that all of the individual arrays had the same size, but it doesn't have to be the case. And they often use the term ragged array or jagged array to illustrate this. So here's a case where we have an array of integer arrays. So it's a two-dimensional integer array. And the first element has a length of 3. So my list at position 0 dot length is 3. My list at position 1 dot length is 2. And my list of position 2 dot length is 1. So they can be different sized within there. And your textbook shows some examples of three-dimensional arrays. It's interesting to look at some of these. So here's the guest birthday example, guest birthday using array example. And it's an array of arrays of arrays, three-dimensional array. And you can see the syntax for this right here. And I'm just going to quickly put a breakpoint. I don't really want to belabor this much. I'll just put a breakpoint to show you what it looks like. And if we look at the data here, we can see these are dates, 5 elements. As we can see, there were 1, 2, 3, 4, 5. And within each element, 1, 2, 3, 4. 1, 2, 3, 4. And then within those, an additional 1, 2, 3, 4. And it was down at that lowest level there that we have the actual integer values. And this asks you some questions and tries to guess what your birthday is. It's an interesting little thing to play with. There's another one for weather as well, calculation as well. So that's the end of our discussion of arrays for now. Again, we will revisit arrays in a little bit more depth when we get into methods. You are going to have an assignment that's going to make use of parallel arrays. That'll be your third assignment, and we'll talk about that later.